Welcome all. Today we are going to learn numerical integration. So numerical integration is the process of finding the value of any definite integral a to b y dx, integration of y over the limit a to b by taking some points spread over the intervals a b. So in this process we don't integrate the function, we just take some points in this interval and we try to find out the value of this integral. Why this method is important? Because there are many functions which cannot be integrated by the usual analytic methods. For example, if the integration is any value from a to b log of 1 by log of 10 x dx, we cannot integrate this as usual methods, but using numerical integration method we can find approximately correct value of this function. Remember that numerical methods always give approximate value. That is why that whatever how many times we are iterating the process makes it more accurate. Okay, and some other example may be x e power 1 by x dx. These functions are not integrable directly, but using this method we can find the value for any given limit. Remember that numerical integration is applicable for definite integrations only. Then only we can find out some finite points and we can find approximate value. Okay, so this is the importance of this numerical integration. So to apply any numerical integration method or formula, we can say we have to divide this interval, whatever the definite integral has given, that interval, that limit, we have to divide in n equal parts of step length h. So if we are dividing in n equal parts, whatever value we are getting, that is called step length. So if I take an example, say this is 1 to 10. Any function we have to integrate using the numerical integration method. So we have to divide this in say 3 or 9 equal parts. So what will be the value? 1 to 10 we have to divide in 9 equal parts. So what will be the length? 1. 1 to 2 is first value, 2 to 3 is second value, like that. If what will be the step length? That will be 1. So then we will get n equal parts. So what may be the formula? Say 10 minus 1 by 9. How many parts we have to divide in? 9. So value 1. So I can take the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many parts are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have divided that interval in 9 equal parts. And what is the step length? That is 1. So step length h is 1. So that is how we can divide. We have to divide that interval in n equal parts. So if I generalize the formula, that step length can be written as b minus a by n. Now second question comes here, how to decide this n? How many parts we have to divide in? So that depends on the method we are going to apply. Each method has its own characteristic. In some methods we have to divide in 3 parts, 4 parts, or multiples of 2, multiples of 3. So that will be discussed with that particular method only. Okay. So but if we know what should be the number of intervals, we can find out the step length. If we know what should be the step length, we can find the number of intervals. Okay. Then if we are dividing any interval in n parts, we get n plus 1 values. So that you can understand from here also. I have divided in n parts, but how many values I am getting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values. If I have to divide any interval 2 to 4 fx dx in 4 intervals, 4 equal parts. 4 equal parts means b minus a by 4. So b minus a means 4 minus 2 by 4. What is the value? 2 by 4, 0.5. So that is the step length h. So if I divide this interval in h, how we have to write? X. So first we will find the value of x and corresponding value of fx we can find. So first value we have to start with 2. Then taking this step length, keep on adding 0.5 here. So next step will be 2.5. Then next step will be 3. What I am doing? I am adding this h here. So So 2 starting from the lower value to upper value we have to go. Then 3.5, then 4. So how many equal intervals we have got? 1, 2, 3, 4. To calculate the intervals, we have to count this difference here in between 1 interval, 2, 3, 4. But how many values? 1, 2, 3, 4, 5. So that means if we are dividing in n intervals, we get n plus 1 points. Those n plus 1 points are called ordinates. Okay. So if question says, or if somebody says that we have divided in 7 ordinates, that means how many intervals we have done? 6. Intervals are always 1 less than ordinates, or ordinates are always 1 plus of intervals. So I hope it is clear. So if I generalize this, what I can say, that if we have values a to b, fx dx, and step length is h, then value can be a plus h, a plus 2h, up to we have to keep on going till the time we get b. Like that we have to keep dividing this interval, and then by substituting this value in the function, whatever function is given, we can find that corresponding values of y or fx. So that is how the main thing here you should remember is, if we are dividing in n intervals, ordinates will be n plus 1. So if ordinates are given, you should be able to find out intervals. If intervals are given, you should understand what is the meaning of ordinates. Okay. Now we will discuss some of the integration formulas, some of the numerical integration formulas. Based on that, we will know what should be the value of n, and we will take some numerical examples. So let's start with a few of the numerical integration methods. So for that, let's say any integration is given as a to b fx dx, which we have to integrate using any numerical methods. So first of all, as I told you, we have to divide the interval in n equal parts. So if I divide this interval in n equal parts with the step length h, so we will be getting few points like starting with a, then every time keep on adding this step length a plus h, a plus 2h, and how many times we have to keep on going? Till the time we reach to the upper limit b. You should automatically get this value b. So if you are not getting it at the last, that means you have made some calculation mistakes. So you please verify this starting with the lower point and keep on adding this step length every time. You will eventually lead to the upper limit b. Then we find the values of y. How to find this value of y? Once we divide this x in n equal parts, we substitute this value of x in this given function fx, since y is equal to fx. So if I put x equal to a here, I'll get whatever value I am getting, I have denoted as y0. Then next value if I substitute here, I will be getting y1. So you will get some values corresponding to each x using y equal to fx. So once we made this table, then according to the formula we have to apply, according to the method we have to apply the formula. So the first method we are going to do today is Simpson's 1/3 rule. So the basic mandatory condition to apply this method is that number of interval that is n must be the multiple of 2. What does that mean? That if I am dividing this interval, that number of interval should be multiple of 2. That means I can divide in 2 parts only. 2 intervals, divide by 2 and take what may be the value. I can divide in 4 equal parts. I can divide in 6 interval. I can divide in 8 intervals. So number of intervals, that means number of values of n we are choosing, that should be multiple of 2. That may be 2, 4, 6, 8 like that. Okay. Then if I have divided this, then this formula says that value of I. What is I? That is what we are going to calculate. This is the value we have to find. Okay. I is given by h by 3. Now what is h? H is the step length which can be calculated with the formula which we have discussed earlier. Let me write it here. H is equal to B minus A by N. First we have to calculate this, then only we will be constructing this table. So by now you must be knowing what is H. Then Y naught plus Yn. Which two values? First and last. So first you write Y naught plus Yn. Then plus 4 times of which values? All the odd values in this table. So that is y1 plus y3 plus what will be the next odd value? y5, like that. So that will depend on the table which you have constructed already. So first and last value plus 4 times of sum of all odd ordinates plus twice of, now what is remaining here? All the even ordinates. So all the even ordinates will go with multiple of 2. So what should I write here? y2 plus y4 plus y6, like that. Okay. So this is the formula to evaluate the integral using Simpson's 1/3 rule. Again I am repeating, for Simpson's 1/3 rule, number of intervals should be the multiple of 2. So once we construct the table, we can apply the formula and we can find the approximate value of the given integral. Okay, so this is the calculation part is given, and the next I am going to write next integration formula. After that we will solve the question for both the methods. So second method is Simpson's three by eighth rule. Okay. Simpson's 3 by 8th rule. So the mandatory condition to apply this method is number of interval, that means value of n, must be the multiple of three. Okay. So when you are dividing the interval, number of intervals you are taking, that should be the multiple of 3. So you can choose 3 intervals, 6 intervals, 9 intervals, like that. Okay. So if that we are applying this method, and so first we have to divide that interval in multiples of 3, then Simpson's method says that integration of this function is equal to 3h by 8. Then 3h by 8, you can remember by this also, 1/3 says 1 by 3, 3 by 8 says 3 by 8. Then first and last value, again y naught plus yn plus, then all the values in this table which is having multiple of 3 goes with 2. 2 into y3 plus what will be the next value? y6 plus y9. I am writing the general formula. Suppose in the table you have only y3, so you have to write only y3. If you have y3 and y6 only, up to here. If you have y9, 12 also, you have to add that. So you have to use the formula as per the available data or available table you have constructed. Plus, now what are left? We have taken first and last and all the multiples of 3. But what is left? y1, y2, then y4, y5, then y7, y8. All those goes with the multiple of 3. So let me write it here, or here only let me, I am writing y1 plus y2 plus y4 plus y5, like that. So whatever is remaining you can write in last. This is y5. Okay. So again I am repeating, first and last value, sum of first and last value plus twice of sum of all the ordinates which are having multiple of 3 plus sum of all the remaining ordinates with multiplied with 3. Okay. So this is the Simpson's 3 by 8 rule. This is Simpson's 1 by 3rd rule. Now here as I have told that here you have to take the interval as multiple of 2. So question that it is possible you can take only 2 intervals, other one can take 4 intervals, someone else can take 6 intervals. So all are correct, but accuracy will be more if number of intervals are more. So the person who is dealing with 12 intervals will be having most accurate value as comparison to 2, 4, 6. So this is your choice as you want to do. If not set, you can use it. Similarly, here also you can start with 3, but if you take more number of intervals, you have to apply and you will be getting more accurate value. Suppose you have to apply both the methods in the same question, then you can choose 6 intervals. So for 6, this is also applicable, this is also applicable. So now we will take some numerical questions and we will understand this better. Okay. So let's take the first example. Evaluate 0 to 6 dx by 1 plus x square using Simpson's 1/3 rule, Simpson's 3/8 rule and compare with actual value. So as you can see, this is not that function which we cannot integrate. So we can integrate this with analytical method. That value we have to find for this, and what value we are going to get with these rules, that we will calculate and then we will compare that how close it is to the real value or the actual value which we get from analytical methods. So first of all, we have to calculate these values using Simpson's 1/3 rule and Simpson's 3/8 rule. Now what is the condition for Simpson's 1/3 rule? That number of intervals should be the multiple of 2. That means we should choose even number of intervals. And for 3/8 rule, number of intervals should be multiple of 3. So here you can do two things. Either you can make a separate table for Simpson's 1/3 rule by taking multiples of 2. Then you can make a separate table for Simpson's 3/8 rule by taking multiples of 3. But what will be smart work? I would say that if we are able to do that in less work, if we are able to do with one table only, right? Okay, so what should be the number of intervals which can satisfy both the conditions? If I choose n equal to 6, then that will satisfy both the conditions for these formulas. So n equal to 6 means multiple of 2. So we can apply Simpson's 1/3 rule. N equal to 6 means multiple of 3. That means we can apply Simpson's 3/8 rule too. Okay, so let's take n equal to 6. It will save our time and what we have to do less work. So first we have to write taking n is equal to 6. Okay, sometimes it is given in the question that take number of intervals as 6. Sometimes they say take 7 ordinates. So remember that ordinates are always plus 1 to the interval. So if it is says 7 ordinates, that means interval is 6. If nothing is given, you can choose as we have chosen here n equal to 6. Then if n is 6, what will be the step length? B minus A. What is B? B is 6, upper limit, minus lower limit divided by 6. So what is the step length? 6 by 6, that is 1. So h is equal to 1. Now let's construct the table. So first we will find out the values of x, all the points. So we have to start with lower limit 0. Then what will be the next point? We have to keep on adding this h here. So 0 plus 1, that is 1. So next point is 1. Then 1 plus 1, 2. Then 2 plus 1, 3. Then 3 plus 1, 4. 4 plus 1, 4 plus 1 is 5. And 5 plus 1 is 6. So as I told you, if you have taken the correct step length, you will lead to the final upper limit. So we have reached to 6. Now we need not to go beyond it. So these are the points of x. Now we have to find the corresponding value of y. Now what is y? Y is the given function which we have to integrate. That is 1 by 1 plus x square. That is y. From where you have to take this? From the given question. So what is the function given here? Fx is 1 by 1 plus x square that is y. Now we have to substitute these values of x in this y and we have to find corresponding values of y0, y1, y2. So here I would suggest you, now let's do first one. If I put x equal to 0 here, so this becomes 0, 1 by 1 is 1. Then if I put x equal to 1 here, 1 square is 1, 1 plus 1 is 2, 1 by 2 is 0.5. Like that you have to find all the values. So I would suggest you pause the video here and you calculate it using your calculator and then later you verify the values. Okay, so I hope you are ready with the table. Now let's see what values we have got. Up to here we had done. For x equal to 2, if you put 0.2, for x equal to 3, 0.1, for x equal to 4, I have written 0.5884. At least up to third decimal point, you should always take the value. If you take up to 4 decimal point, that is better. So at least third decimal point, you should always take the value. Then x equal to 5 gives 0.0385 and x equal to 6 gives 0.027. So if there is any difference at third or fourth decimal, that is okay, because if someone has rounded it, that will give a minor, just minor difference. So that is okay. So up to here we have calculated, we have got the table. Now n equal to 6 gives a multiple of 2. Again I am telling for Simpson's 1/3 rule, n equal to 6 is also satisfying the condition for Simpson's 3/8 rule. That should be the multiple of 3. Now we know the formula for both the methods. We have to apply one by one. So Simpson's 1/3 rule says, what is the Simpson's 1/3 rule? That I is equal to h by 3 first and last value y0 plus yn plus, what was the next value? Okay. So what is yn here? Yn is y6. For that I would suggest you, let's write it here. y0, y1, y2, y3, y4, y5, y6. So we were writing the formula h by 3, y0 plus yn, then all the even values with 2. So y2, y4, y6, like that, plus with 3, with 4, all the odd values, y1 plus y2, y3 plus y5. Okay. So here I would suggest you that first value you should write y0, last value you should write yn. Otherwise what happens while substituting this even value, that repeats sometimes by mistake. So first and last you make y0 and yn. Then remaining value y1, y2, y3, y4, y5. So that by mistake you will not repeat any value. So we have written this. Now we have to just write the values and calculate. What is h? H is 1. 1 by 3. What is y0 plus yn? 1 plus 0.027 plus twice of y2, y4, y6. y6 is not there. So 0.2 plus 0.5884. Then 4. y1 0.5 plus y3 0.1 plus y5 0.0385. So I hope it is clear how we have substituted value. Again I would remind you that it's better to write y0 and yn at first and last value. Otherwise if you write y6 here, what happens? You again repeat this value. You write that here also and here also. So to avoid that, to keep that chances of that mistake minimum, y0 and yn you write like this. Remaining value starting with y1, y2, y3, y4, y6 and if any is there. Then substitute the corresponding values in whatever values you have to write. Use your calculator and find out the value. So I hope you are ready with the answer. The approximate value of this integral using Simpson's 1/3 rule is 1.3662. So if there is any difference at that fourth decimal place or third decimal place, that is acceptable, but you should not get a difference at second decimal place, because in approximate value difference at second decimal place is considered as use difference. Okay, so you make sure that you have calculated and substituted values correctly and you are getting the approximate value as this. So this is Simpson's 1/3 rule. Now we will apply Simpson's 3/8 rule and we'll get the value. So next is Simpson's 3/8 rule. What is the formula for that? That value is given as 3h/8, then first and last value, then twice of all the multiples of 3, y3 plus y6 plus y9 like that, plus 3 of all the remaining values. So y1 plus y2 plus y4 like that. Okay. So this is the formula. We are already ready with the values of these y0, yn and h. Let's substitute the value. So h is 1. So I is equal to 3/8. y0 plus yn is again 1 plus 0.027 plus twice of multiples of 3. Now you see where are the multiples of 3? We have only one value, y3. We don't have y6. So only one value. We have to substitute it here, 0.1 plus thrice of all the remaining values. So which one we have already taken? This, this and this. So remaining values we have to put 0.5 plus 0.2 plus this we have taken. So 0.5884 plus 0.0385. Calculate this value using your calculator and find out the value. Okay. So after calculating this value, we are getting approximately 1.3571. So Simpson's 1/3 rule gives this value, 3/8 rule gives this value. So but in this question we are asked to compare it with the actual value. So we will do it by direct integration and we'll see which one is closer. Okay, so let's solve it. Okay, so let's see now what we are getting by direct integration. So what is the integration of 1/1 plus x square? That is tan inverse x. Limit over 0 to 6. So if we substitute the value, tan inverse 6 upper limit minus lower limit. So tan inverse 0 is 0. So this is equal to tan inverse 6. This value you can find using your calculator. So if you use your calculator, you must be getting 1.4056. So by direct integration, we are getting 1.4056. Simpson's 1/3 rule gives 1.3662 and 3/8 rule gives 1.3571. Which one is closer to that value? This one. This one is closer. So out of these two methods, Simpson's 1/3 rule gives more accurate value than this. So if we have the choice, we should use this method to get the accurate value, means better accuracy value. Okay, so I hope you understood the method. Keep practicing. Then the next method we'll do in next video.